NASA needs 3 rockets to build moon base. Last night, one of them exploded on the launch pad. At approximately 9 p.m. Eastern Time on May 28, 2026, a New Glenn rocket, Blue Origin's heavy lift vehicle, detonated during a pre-launch engine test at Cape Canaveral. The fireball engulfed the launch pad. The upper stage tilted and collapsed as the first stage disintegrated beneath it. The transporter erector was destroyed. At least one lightning tower was toppled. As the smoke cleared, there was no sign of the rocket or much of the pad infrastructure. Residents along Florida's Space Coast reported feeling the shockwave in their homes. The fireball was visible from miles away. By the time the first responders reached the pad, the 98-meter rocket had been reduced to debris and scorched concrete. No one was injured. And the timing could not have been worse, because this rocket was not just another commercial launcher. 2 days earlier, on Monday, NASA had announced nearly $1 billion in contracts for Moonbase. Blue Origin was on the list. Its Blue Moon lander was scheduled to launch on a New Glenn rocket this fall, carrying the first payloads to the lunar South Pole. That rocket is now gone. The pad that held it is damaged, and the mission it was supposed to carry no longer has a way to get there. Jeff Bezos posted within hours. Very rough day, but we'll rebuild whatever needs rebuilding and get back to flying. NASA Administrator Jared Isaacman responded, "Spaceflight is unforgiving, and developing new heavy-lift launch capability is extraordinarily difficult." Both statements are true. Neither answers the question the data raises. How much time did Moonbase just lose? China has announced a crewed lunar landing target of 2030. The margin between the American and Chinese programs was already measured in months, not years. Every delay to Moonbase compresses that margin further, and last night was a significant delay. A static fire test is the final rehearsal before launch. The rocket is fueled. The countdown runs. The engines ignite for a few seconds, long enough to verify thrust, propellant flow, and vehicle response. Then they shut down. If everything checks out, launch follows within days. Last night's static fire caught a problem. The problem caught the rocket, and if the problem turns out to be inside the engines, the consequences may extend far beyond Blue Origin. What exactly failed is not yet known. Blue Origin has said only that they experienced an anomaly. The timing of the failure, during or immediately before engine ignition, points to a narrow range of possibilities. Propellant system malfunction, turbopump failure, combustion instability. Each has precedent. Each takes months to resolve. To understand what was lost last night, you need to understand how long it took to build. New Glenn was announced in 2016. It was supposed to fly by 2020. It did not fly by 2020, or 2021, or 2022, or 2023, or 2024. For nearly a decade, New Glenn became the rocket that never seemed to arrive. The problem was always the same: the BE-4 engine. A methane-fueled staged combustion engine so complex that Blue Origin spent over 13 years developing it. A test engine exploded during qualification in June 2023. Production rates fell behind what customers needed. United Launch Alliance, which uses the same engine for its Vulcan Centaur rocket, publicly called BE-4 deliveries the pacing item in its own launch program. Then, in January 2025, New Glenn finally flew. 5 years late. It reached orbit on its first attempt. 2 more flights followed, both successful. The program was accelerating. Monthly launches appeared possible by 2028. For the first time in Blue Origin's 25-year history, everything was working. The 4th vehicle was stacked on the pad for a static fire ahead of a June launch. It never fired. 3 successful flights. And then, a fireball at 9 p.m. on a Thursday in May. To understand why one rocket explosion affects a program to build a permanent base on the moon, you need to understand how Moonbase is structured and why it cannot rely on a single launch vehicle. NASA's Moonbase plan, announced on May 26th, 48 hours before the explosion, unfolds in phases. The first missions are robotic. Instruments, rovers, and technology demonstrators delivered to the lunar South Pole to characterize the environment and reduce risk for crewed landings. The later missions are crewed, astronauts arriving at habitats and infrastructure that was placed there ahead of them. Each mission requires two things: a lander to reach the surface and a rocket powerful enough to send that lander to the moon. NASA does not build its own rockets anymore. It contracts them from commercial providers. And for Moonbase, it has contracted 3 primary vehicles, each built by a different company, each serving a different role. SpaceX's Starship is the largest. At 120 meters tall, it is the most powerful rocket ever built. It is the primary vehicle for the Artemis Human Landing System, the spacecraft that will carry astronauts from lunar orbit to the surface. Starship is reusable, enormous, and still in active development. 11 integrated test flights have been completed. Orbital refueling, a capability required for lunar missions, since Starship cannot carry enough propellant to reach the moon on a single launch, has not yet been demonstrated. United Launch Alliance's Vulcan Centaur is the workhorse, a medium to heavy lift rocket powered by 2 BE-4 engines built by Blue Origin. Vulcan handles national security payloads, commercial satellites, and NASA science missions. It is operational, reliable, and flying regularly. Blue Origin's New Glenn was the third leg. A heavy-lift rocket also powered by BE-4 engines, 7 of them clustered in the first stage. New Glenn was designed to carry Blue Origin's own Blue Moon landers to the moon, to launch Amazon's satellite constellation, and to compete with SpaceX's Falcon Heavy for commercial and government contracts. That third leg is now gone. The launch pad that supported it is damaged. The timeline for return to flight is unknown. Here is what Blue Origin was contracted to deliver for NASA, and what now hangs in the balance. Moonbase 1 was the first mission, targeted for launch no earlier than fall 2026. The Blue Moon Mark 1 Endurance Lander, an uncrewed cargo vehicle capable of delivering up to 20 metric tons to the lunar surface, was supposed to land on Shackleton Connecting Ridge near the South Pole. Its payload was not science for the sake of science. It was survival data for future astronauts. Stereo cameras to study how thruster exhaust behaves on the lunar surface, so that crews arriving later would know what their landing looks like from above. A laser retroreflective array to help orbiting spacecraft pinpoint landing sites to within meters, so that astronauts would land where they intended, not where debris or slope made survival uncertain. Without that data, NASA must either send astronauts to the surface with less information, accepting more risk, or delay the crewed missions until the data arrives. That is just the first delivery. The list is longer. Moonbase 2 was planned for later this year, using a different commercial lander carrying a mobility rover. Moonbase 2 does not depend on New Glenn, but the crewed missions do. The Blue Moon Mark II, the crewed version of the lander, was selected by NASA as one of 2 human landing system providers alongside SpaceX's Starship. The Mark II is scheduled to support Artemis 5, currently targeted for 2030. It will carry astronauts from the Orion spacecraft in lunar orbit to the surface and back. A version of the Mark II is also slated to participate in Artemis 3 as an Apollo 9-style demonstration in low Earth orbit, a dress rehearsal to buy down risk before committing astronauts to a lunar landing. That demonstration is currently scheduled for mid-2027. Both versions of Blue Moon are designed to launch on New Glenn. The Mark I fits on a single New Glenn flight. The Mark II requires orbital refueling but still needs New Glenn for the initial launch. The landers exist. They are being built at a separate production facility at Cape Canaveral, less than 10 miles from the pad where New Glenn exploded. The Blue Moon Mark I is in advanced stages. Its 3 modules were being stacked at the time of the explosion. The engineers assembling the lander may have seen the fireball from their facility. They were building a spacecraft to land on the moon. Last night, the rocket that was supposed to take it there burned in front of them. The landers have no way to reach orbit without the rocket. And then there is the part of this story that extends beyond Blue Origin. Remember the BE-4 engine, the one Blue Origin spent 13 years developing? The one that may have been involved in last night's failure? Blue Origin does not use that engine alone. The BE-4 also powers United Launch Alliance's Vulcan Centaur, a separate rocket built by a separate company carrying a completely different set of missions. Vulcan handles classified national security payloads for the Department of Defense. It launches NASA science missions. It is operational, reliable, and flying regularly. It runs on the same engine that was at the base of the rocket that exploded last night. If the root cause of the explosion is traced to a BE-4 failure, a turbopump defect, combustion instability, a manufacturing flaw, Blue Origin does not just lose New Glenn. NASA could lose 2 launch vehicles from a single failure. This is not confirmed. The explosion may have originated in propellant systems, ground equipment, or ignition software, subsystems unrelated to the engine. The investigation has barely begun. But if both New Glenn and Vulcan are grounded simultaneously, NASA loses access to 2 of its 3 primary launch vehicles, leaving SpaceX's Starship as the only heavy-lift path to the moon. That is not redundancy. That is a single point of failure for the entire lunar program. And here is the part that makes the situation worse. SpaceX's Starship, the supposed fallback, the one remaining heavy-lift path to the moon, has not yet demonstrated orbital refueling. Lunar missions require multiple Starship launches to fuel a single vehicle in orbit before it can reach the moon. That capability was originally expected by mid-2025. It has not been completed. The timeline has slipped repeatedly, which means, as of tonight, New Glenn is grounded, Vulcan may be affected, and Starship, the backup, has not yet proven it can do the one thing Moonbase requires of it. All 3 legs of the architecture have problems. The question is no longer which vehicle will carry Moonbase forward. The question is whether any of them will be ready on time. Redundancy is not a luxury in spaceflight. It is the architecture. The reason NASA contracts multiple providers is the same reason the International Space Station maintained both Soyuz and shuttle access for decades. When the Space Shuttle Columbia was destroyed in 2003, NASA grounded the entire shuttle fleet for over 2 years. During that period, only Russian Soyuz vehicles could reach the station. When the shuttle retired permanently in 2011, NASA had no American vehicle capable of carrying crew to orbit, a gap that lasted 9 years until SpaceX's Crew Dragon flew in 2020. Those gaps were painful. They were also survivable because alternatives existed, even if those alternatives were Russian. Moonbase has no Russian alternative. There is no international partner with a heavy-lift vehicle capable of carrying Blue Moon landers to orbit. If New Glenn is grounded for a year and Starship encounters its own delays, which it has repeatedly throughout its development, the only option is to wait. SpaceX's own history illustrates the risk. On September 1, 2016, a Falcon 9 rocket exploded on the pad at Launch Complex 40, Cape Canaveral, during a pre-launch fueling operation. The same type of ground test that destroyed New Glenn last night. The explosion destroyed the rocket, the payload, a $200 million Amos 6 communications satellite, and severely damaged the launch pad. SpaceX returned to flight 4 months later, in January 2017. But Launch Complex 40 took over a year to fully rebuild. During the grounding, SpaceX shifted all launches to Launch Complex 39A at Kennedy Space Center and to Vandenberg Air Force Base in California. Blue Origin does not have that option. Launch Complex 36 is its only orbital launch site. A second pad is under development at Vandenberg Space Force Base, but it is not yet operational. If the pad damage at LC-36 is as severe as initial reports suggest, the transporter erector destroyed, at least one lightning tower toppled, the pad surface potentially compromised by the fireball and the collapse of a fully fueled 98-meter rocket, The rebuild timeline could extend well beyond SpaceX's 4-month precedent. The rocket can be replaced. Blue Origin has additional vehicles in production at its factory adjacent to the Kennedy Space Center. The pad cannot be replaced. It must be rebuilt. The timing is what makes this consequential. Here are the dates that matter. Moonbase 1, Fall 2026. The first robotic delivery to the lunar surface, now almost certainly delayed. Artemis 3 demonstration, mid-2027, a dress rehearsal for the crewed landing. Depends in part on Blue Origin hardware. First crewed landing on the moon since 1972, 2028. Depends on data from the robotic missions that must arrive first. China's crewed lunar landing target, 2030. Every month of delay in the precursor missions compresses the timeline for the crewed missions that follow. The schedule does not have slack. It was not designed with slack. Every date on that list was already described as ambitious before last night. NASA Administrator Isaacman said on Tuesday, 2 days before the explosion, that Artemis 3 was on track for mid-2027. The margin was thin before last night. The president and I want to get to the moon in this president's term, said Transportation Secretary Sean Duffy in an October 2025 appearance on CNBC. Last night, that margin got smaller. Here is what the data confirms. Blue Origin's 4th New Glenn rocket was destroyed during a static fire test on May 28, 2026 at Launch Complex 36. The launch pad infrastructure was severely damaged. No injuries were reported. The root cause is under investigation. The rocket was scheduled to launch Amazon Kuiper satellites as early as the following week. Moonbase 1. The first robotic delivery to the lunar South Pole was planned for later this year on a New Glenn vehicle. Blue Origin's Blue Moon Mark II crewed lander is scheduled for Artemis 5 in 2030. NASA awarded Blue Origin nearly $1 billion in moon-based contracts 2 days before the explosion. Here is what the data does not yet tell us. Whether the failure originated in the BE-4 engines or in ground systems, whether Vulcan Centaur operations will be affected, how long the launch pad will take to rebuild, whether Moonbase 1 will be delayed, and if so, by how long, whether the Artemis 5 human landing system schedule can be maintained, whether NASA will seek alternative launch vehicles for Blue Moon payloads. The history of spaceflight is a history of explosions, followed by investigations, followed by redesigns, followed by returns to flight. Every major launch vehicle flying today has survived a failure. Atlas, Delta, Falcon 9, Soyuz, Ariane. The shuttle, twice, at the cost of 14 lives. Blue Origin will return to flight. That is not in question. The question is, when? And whether when is soon enough for a moon base that was already running out of margin. NASA announced Moonbase on Monday. Blue Origin was a cornerstone of the plan. By Thursday night, the rocket that was supposed to carry the first mission was burning on the pad at Cape Canaveral. Spaceflight is unforgiving. Isaacman was right about that. The booster that exploded had a name. Blue Origin names its New Glenn boosters. This one was called No, It's Necessary. It was a reference to a line from Interstellar, a moment where a character overrides caution in pursuit of a goal that cannot wait. The irony needs no explanation. The pad at LC-36 is dark tonight. The rocket is gone. The erector is gone. The lightning tower is down. The investigation is beginning. Nobody knows yet whether Moonbase lost 3 months or 3 years. That answer depends on what the investigation finds and whether the problem is in one rocket or in the engine that powers 2. Somewhere in a production facility at Cape Canaveral, the Blue Moon Mark I lander, the one that was supposed to ride New Glenn to the moon this fall, is waiting. It is finished. It is tested. It has no ride. The moon has been waiting for 53 years. It will wait longer if it has to. The question is whether we can.